Hello, SAM fans, and welcome to this SAM Science Edition or GCSE Physics Momentum. This is only for higher content for Edexcel and AQA. So if you are doing the foundation, you do not need to know this. Okay, so momentum. What is momentum? Now, momentum is one of those topics that a lot of students do struggle with. They look at the question and they get really confused with all the numbers and what the question is asking. So actually, momentum is or can be quite a scary topic if you don't know how to answer the question. So first of all, what is momentum? So momentum, as a quick definition, is the product of a moving object's mass and velocity. So it can involve two objects that have got both mass and velocity, but one can be stationary and one can be moving. But generally, it's the product of a moving object's mass and velocity. So the end result, if you like, of both an object's mass and velocity. Now, an object can be stationary, as I mentioned before, and if that's the case, it would just be zero. But this is when objects pretty much collide. So you can have a stationary object, a moving object that can collide with a stationary object. Now, momentum is vector, meaning it has both direction and magnitude. So let's start with the equation first. So you may have come across this equation in my GCSE physics equation video, but as I say, it's always good practice to put the momentum equation in a triangle so you know what you're trying to work out. So this is the basic question that you could get on momentum. So for this, it's asking you what's the momentum if the mass is 13.5 and the velocity is 0.8. Now it's given it here for us already. So it's asking us to work out the momentum. So we cover up momentum, okay? Let's draw a line or something just so we know that we've crossed that out. And then we do mass times velocity. So that's 13.5 times 0.8. Okay, and do that in your calculator, and then that should give you an answer of 10.8 kgm/s. Now, kgm/s is the unit for momentum. So if you didn't know that, that is something, of course, that you do need to know. Okay, so calculating momentum isn't actually too difficult. It's when it's talking about the collisions and the law of momentum, that's when things become a bit more tricky. So the main rule when it comes to momentum and collisions is the momentum is conserved. So what that means is whatever the momentum is before the collision or explosion or crash is exactly the same as after the collision or explosion or crash. So whatever it is before will always total after because it's being conserved. So I thought it'd be time for a meme just to lighten the mood. So when you gain momentum, do you get it? Because you're moving and you got mass. Sam, you're funny. Oh no. All right, come on then. Let's focus. Let's focus. So here's an example of a typical exam question where it is actually using collisions, or in this case, is explosion. So calculate the momentum of the bullet, and then it's asking how can we find the velocity of the gun. So this is a very good example of momentum conservation. So if we remember our triangle, let's draw it out again because the triangle pretty much gives us the answer. So there's two things here that we need to consider. First of all, it's asking us what the momentum of the bullet is. Then it's asking us what the gun's velocity is. So draw this out. So here we should have not M, should be P, which is your momentum, and then here's your mass. Now we've got all those details for the bullet. What we don't have those details for is for the gun. So the bullet has a mass of 0.1. So get the calculator out, and then you do there. We want to work out the momentum. So all we're going to do is do 0.01 times 150, which gives us a total of 1.5. That's the momentum of the bullet, but it's asking us for the gun as well. Now we've got the mass of the gun, which is 1.5. Now, going back to what I said about conservation of momentum, that it stays the same. Okay, it does not change. So the momentum of the bullet, as we said, is 1.5 kgms. You can see here the total momentum before firing a gun is 0 because it's stationary. Nothing is moving, okay? But the momentum of the gun then itself, we've got the mass, but then itself must be minus 1.5, because what's happening there is that the gun itself is acting in the opposite direction of the bullet. And because it's acting on the opposite direction of the bullet, it's creating a negative value, and therefore it'll be negative 1.5. So therefore, if that's the case, the velocity must be exactly the same as the bullet there, which is, as we've got there, so the velocity of the gun, so we do 1.5 divided by 1, which then gives us 1.5 anyway. Okay, so it's the same as the bullet. Whatever the bullet was in the first place, it will be exactly the same for the gun as well. All right, so this is a question that can trick you. What you just need to remember is the conservation of momentum. So whatever is on one, if you like, part of the object is going to be exactly the same as the other, because it's being conserved. And the two objects here are the gun, and the other object is the bullet, and they're working oppositely. Okay. Gosh, that was a lot of information we just went through. Time for a meme. So I submitted a theory about inertia. I like this cat, it's my favorite cat, but it isn't gaining momentum. So inertia, in case you didn't know, is basically when you don't want to do anything or don't want to change anything. So it's inertia. So that was a laugh out loud moment, that was. Okay, right. Typical exam question. You've got two objects. They are moving in opposite directions and they're going to collide. So we want to know what their momentums are before they crash. And it says the momentum must be the same after the crash. So what's the velocity when they do? Look here, you've got plus and you've got minus. Plus means it's going to be a positive number, so it's going one direction, and then the other object or the other person has got negative. So that means is that person is working in the opposite direction, therefore it's going to be of a negative value. So this one here is going from left to right, and then this one here is going from right to left. So what's the momentum before they crash? So first of all, we need to remember is the equation. So we should have, first of all, we should do, bearing in mind, remember that it's going to be a minus, okay? So we should have, we've got the mass, which is 60 times 1.5, which gives us minus 90. That's for that person there. And then this one is 80 times 2 equals 160. Okay, and then kg/ms. kg/ms. Put that here. Can't move that. Okay, that's fine. Okay, cool. So that's the answers for that. So what the momentum, what's both them, Sam's and Christina's momentums before they crash? We've got that. That's half of it. And then the momentum must be the same after the crash. So what's their velocity when they do? So how do we work this out? So we've done half of the question. So what do we then do here? So we've got it here. You add them then together, which then gives you 70 kg/ms. Why is it 70? Because remember 90 is a negative. Okay, so you do negative 90 plus 160, as I've got here, which gives you 70 kg/ms, and that's their total momentum. And then it's asking you what's after the crash. So what's the velocity when they do obviously crash? So you take the total and then you divide that by 140, because we've got it here. And we need to know, and their velocity then would be 0.5. Now, this is a perfect example of rearranging the equation. So let me draw my triangle. So there we go. Now, this is why I say to you, it's really important that you memorize these equations, especially using these triangles, because you will be able to know what to do. So it's asking for the velocity, so that's mass. Because we don't know what the velocity is when they do. I can't move that M now. Let's just put it here. Right, V. So we want to know what exactly, we want to know what the velocity is. So I'm going to get my rubber and I rub out V. So then we do P, which is momentum divided by mass, because the subject here is velocity. So the P, which is momentum of both the two people, is 70 divided by 100, and 40, which is their mass after the crash, then gives us a total of, in the calculator, is 0.5 ms. Okay, and that is how you should be able to work out the velocity or the momentum with the moving objects. Now, key things here to remember, that if it's a negative, it's going in the opposite direction of the object. And it's also key to remember that if one object is stationary, then they will still absorb all of the momentum from the moving object, exactly the same. It does not change because they are absorbing and conserving their momentum from the object. So it doesn't disappear, doesn't go anywhere. It's pretty much absorbed by the object. So it will take on the momentum of that. So thank you very much for watching the video. Please do watch and share the other videos that I posted on Sam Science, and take care for now. Thank you very much, Sam fans.